So multiplication principle is when I have a task T and they can be completed in k successive steps. Now, can be completed in steps means the task inside the stack is dependent. So let's suppose I got in step 1 can be completed in n1 different ways, step 2 can be completed in n2 different ways, and so on. Then T can be completed in n1 times n2 times nk different ways. Let's recall our first example where we got 3 pens and 2 markers. Now the question is asking here different thing, which is it's asking how many ways can pick a pen and a marker, and he shows the dependency. So first, one can pick either pen 1 or pen 2 or pen 3. Then in each pen, in each time, they can pick either marker 1 or marker 2. And here we got again either marker 1 or marker 2. And here either marker 1 or marker 2. So here we got that task 1 as picking a pen. And task 2 is picking a marker. Now, in order to complete this task, then I got 3 ways on picking the pen and 2 ways on picking a marker. So I got here 6 ways to do so. Pen 1 M1, pen 1 M2, or pen 2 M1, pen 2 M2, and so on. Alright. The example here says that, let's suppose I got 3 studios. Studio A and Studio B and Studio C. Now to go from A to B, there are 3 different ways. To go from Studio A to Studio B, I got 3 different ways. And to go from B to C, there are 4 different ways. Now, in case somebody wants to go from Studio A to Studio C, how many ways are they? So, we need just to define our task here. Task 1, we got 3 ways from A to B. Task 2, we got 4 ways from B to C. Now, somebody can go first way from A to B, then last way from B to C. And somebody goes from the second way, and here also the second way. So to just find how many ways this task can be completed, we need just to multiply 3 times 4. Then we got that there is 12 ways to complete the following task. Now let's move to our next example, which is, let's suppose we need to form a word of length 3. So here I need to form a word with 3 letters, and they can be written only using the following letters, which are A, B, C, D, and E. Now, in how many ways I can form this word where no repetition of the letter is allowed? Okay, so Here we got how many letters? We got 5 letters. So in task 1, we need to choose the first letter, then task 2 is choosing the second letter, and task 3 is choosing the third letter. Now, in order to do so, we need to put this condition in our mind, which is letters cannot be repeated. For example, add is not from the word that can be presented in here, because they have repetition in here. Add or dad is also wrong. So I have to fill the first place. I got the whole 5 letters. Then using 1 letter means I get remaining 4. Then the last one, I can use the remaining 3 letters. So in order to do the task, I got to multiply task 1 by task 2 by the ways that those tasks can be done. Then we got here that they are 5 times 4 times 3, which is I got 16 ways to do so. Okay, now here we got that the same problem, forming a word with length 3 with the same letters, which are A, B, C, D, and E. However, here the repetition is allowed, so add is allowed in this example. So we got the same task, task 1, task 2, task 3, the same as in example 4, which is choosing the first letter, second letter, and third letter. However, the number of letters will be the same because it can be repeated. So in order to forming this task, I can put all the 5 letters in the first letter and all the 5 letters in the second, and again all the 5 letters in the third. So here we got 125 ways to form this word. Okay, now here we need to find the number of license plates that can be written with 3 uppercase letters followed by 3 digits. So here we got 1, 2, 3, and they should be a letter, and then we got 3 digits. So first task 1 is choosing letter 1. Task 2 is choosing letter 2. Task 3 is choosing letter 3. Then we got task 4 as choosing digit 1. Then task 5 is choosing digit 2. And task 6 is choosing digit 3. So fill the first with 3 letters and then 3 digits. Now the possible letters that can be filled in the license plate here is 26 letters. And the possible digits that can be filled in the license plate here is from 0 until 9, which are 10 digits. Now, in order to complete the following task, then I got 26 times 26 times 26, then 10, 10, and 10. And here we got 1757600 ways. And see here, there is no condition, only filling with 3 letters followed by 3 digits. Okay, another example. 2 faced red and blue dice are rolled. Determine the number of possible outcomes. Now, task 1 is rolling red die. Okay, task 2 is rolling blue die, and both of them, they got 6 ways to be shown in the top face. Therefore, the possible outcomes we got here is 6 times 6, which are 36 ways. Okay, here if a set has n distinct elements greater than 0, then find the number of subset of A. First of all, let A and B be sets. Then let B be a subset of A, which can be represented as the following symbols. So here we got that B is a subset of A. Now, in order to construct the decision whether B is a subset of A or not, then we need to know the elements of A. So let's suppose A got x1, x2, x3, and so on. So in order to check whether B is a subset of A or not, then we need to find if x1 is an element of B or x1 is not an element of B. So I need to check the elements of A. They are in B or not. So we'll be asking the same question continuously until I finish all the elements on B. So here we got that I have 2 tasks in here. Whether x1 is an element of B or x1 is not an element of B. Therefore, as the number of element I got, I keep asking the same 2 questions. It is element or not? It is element of or not? And continuing until n times based on the number of an element of A. Then I am getting that to find the number of subset of A, then I can write it as 2 to power n, which is n represent the n times, which is represent the elements. Here represent the number of elements of set A.